Again, thanks for joining us again. I am again Richard Broida, the Azure Application Development Director for Bennett Adelson. This talk is going to be about rapid Kubernetes development with Azure Dev Spaces. And what's that? Well, this talk is going to be a little bit technical, but I'm going to try to not get too bogged down in details. In fact, that's one of the themes here, is how to get started with Kubernetes without getting too bogged down in details. But I will review just briefly what Kubernetes is and what Azure Kubernetes Service is, and the reasons why you might want to consider using them if you're not using them already. Then I'm going to talk about Azure Dev Spaces and what that brings to the experience for developers, and then do a couple of demos. The first one will be showing you one of the main benefits that I see for Azure Dev Spaces, which is that you can get yourself up and running and started using Azure Kubernetes Service and hence Kubernetes very, very quickly, even if you know very little already about Kubernetes. And then the second point is one of the main use cases for Dev Spaces is allowing multiple developers to work on the same set of application services at the same time without getting in each other's way and without needing to replicate the entire environment in each developer's personal space. So, in a nutshell, Kubernetes is a way of running applications in containers at scale. Containers are lightweight virtual environments in which your application runs. It's a smaller, faster equivalent of a virtual machine. The most popular platform for running containers now is Docker, and that's what Azure Kubernetes Service supports right now. If you're already familiar with Docker, I'm not going to say a whole lot more about it. The Kubernetes architecture arranges your Docker containers into clusters. Each cluster it consists of a series of nodes. There are two kinds of nodes: a master node, which governs the whole thing, and then individual worker nodes where the containers actually run. A typical cluster will have 3 worker nodes, and you can scale them up to have quite a few worker nodes. And you can also have multiple containers inside each node. Now, in most situations, in most Kubernetes installations, a node translates to a machine, either a physical machine or a virtual machine. In Azure Kubernetes, it will be an Azure virtual machine. So you can think of that as being the computer that's running the node. And then containers are installed into things called pods, which each pod can contain more than one or more containers. And then the master node orchestrates and manages this whole system for you. The master node will make sure that all the nodes you've built and all the containers and pods running inside those nodes are healthy. If anyone becomes unhealthy or unresponsive, master node will remove it from the cluster and replace it with another one containing exactly the same container image as the previous one. This allows you to easily scale both out by increasing the number of nodes or increasing the number of pods within each node. It provides on runtime load balancing, and it also allows you to do rolling upgrades. So if you have a new version of a container that you want to put into the cluster, the Kubernetes master will take each container down one by one and replace it with your new container, but the whole system continues to run and function without any downtime. This arrangement is particularly well suited for a microservice architecture where the usual practice is to say, I'm gonna divide my total solution up into individual microservices. You put each type of microservice into its own type of container, and then you tell Kubernetes, here's how many instances of this kind of container I want. This is how many I need for that. And the other thing that the Kubernetes architecture does is it arranges for networking and communication between the pods within the cluster, so you don't have to go through normal networking processes in order to have everything work together. So that's a quick high-level view of what Kubernetes is. Now, you can host Kubernetes any place on any set of computers that are running Linux or Windows, and probably other operating systems too, but those are the two that we know about. Why would you want to host it in Azure Kubernetes Service? Well, for one thing, you get a pay-as-you-go pricing model. So just like any workload that you put in the cloud, you don't have to buy hardware, you don't have to maintain hardware. Microsoft takes care of all that for you. You get the usual benefits of being in the cloud, which are high availability, high performance, and easy, unlimited scaling to add or reduce the capacity that you have. Microsoft in the Azure Kubernetes Service provides the master node. So again, that master node in the middle here, you don't have to actually set that up yourself. You don't have to run it. Microsoft takes care of that. Microsoft also maintains the actual Kubernetes software itself and will upgrade it. So if there's a security bug found in Kubernetes itself, Microsoft will patch that for you. And then you also get the ability to easily integrate your Kubernetes solution with lots of different other services that are available in Azure. Some of these you can incorporate into Kubernetes itself. So for instance, Kubernetes typically has a public access point. Kubernetes cluster typically has one or more places where the outside world can talk to it. That's called an ingress point in Kubernetes language. And you can use Azure Load Balancer and Azure Firewall to control access to your ingress. You can also use Azure Active Directory to secure things. Your Docker images need a container registry. You have one built into Azure that you can use. You can use Azure Monitor to provide one-step, one-place monitoring of Kubernetes clusters along with all your other assets in Azure. And you can use Azure External Data Stores, either Azure Storage or any of the myriad kinds of Azure databases to hold data outside the cluster if your containers need it. Now, one of the hurdles of getting started with Kubernetes, if you haven't been using it before, is that there is a learning curve. Microsoft has a training module for Kubernetes called 0 to Hero in 50 days. Well, 50 days to me is a pretty long time to get up to speed on something. Azure Dev Spaces is a set of developer tools and services that drastically reduce the amount of time you need to start running applications in Kubernetes, even if you're not a Kubernetes hero, even if you haven't done your 50 days yet. It's not to say that you wouldn't want to be knowledgeable about Kubernetes as you go along, but this gives you a way to get started. And again, one of the things I believe in is that development processes should change incrementally. You can instantly containerize a new or existing app and run it in Azure Kubernetes Service. Remember that if you have an app that's just running plain on-premise or running in a simple Azure environment like Azure Application Services, in order to put it in Kubernetes, you first have to Dockerize it by creating a definition for a Docker container that you're going to put it in. Then you have to create Kubernetes manifests, which will tell Kubernetes how to install and run these containers. And then you have to use a tool called Helm, which H-E-L-M, which will install your application code into the containers once they've been deployed into Kubernetes. The Azure Dev Space service will take care of all those steps for you, which I'm about to show. And on top of that, you also then once you've done it, you get live debugging. So you can put breakpoints in your code and have them stop and run and give you the full debugging experience within Visual Studio or Visual Studio Code. This means that you don't have to set up local Kubernetes environments on your individual developer workstations, which can be a challenge for newcomers to Kubernetes, or I call them Kube-newbies. And it also means you have to worry about consistency. Does everybody have their local machine set up and running the same way? Now, there are some limitations to it right now. The first is that it only works with applications that can run on Linux. Does not support Docker or Windows containers as yet. I would imagine eventually it will, but right now it works with .NET Core applications because they can run on Linux, also Java and Node.js. And the other thing just to say up front is that this is only intended for development and testing, not for production. So even though we will be setting up a Kubernetes cluster, we're not supposed to be running production workloads on it. Okay, so now I'm going to show you the bare bones of how we go about using Kubernetes with Dev Spaces. So first I need to create my Kubernetes cluster, and I can do this in either through the Azure portal, or I can do it through PowerShell or through Azure CLI. I already have one created here. It takes a little time to create one, so I'm not going to do it actually in the demo, but if I did want to create one, it's pretty simple in the portal. I just type Kubernetes in here. A service, here it is. And, you know, basically I just fill out what region do I want to be in? What do I want to name my Kubernetes cluster? What version of Kubernetes do I want to use? I'll just take the default. And importantly down here, I get to choose my node size. This is important because this is the cost factor. Right now, there is no free version of Azure Kubernetes Service. There may be sooner or later. There is one now for Azure SQL. But right now, you are going to be paying for the virtual machine capacity, essentially. And if you look at this closely, if you're familiar with Azure virtual machines, the sizing of Kubernetes clusters and the price points for them are very similar to the price points you would see if you were setting up an Azure virtual machine. The default here is, oh, the price just went up. Yesterday, this was $80-something. It's now $92.71 per month. So I'm going to tear this down. As soon as I'm done with this demo, I'm going to destroy this cluster so it doesn't eat up my subscription. But for a working situation, you would set this up and you would have this available for your development and possibly your testing team. Once you have your cluster set up, the other thing you do is you go down to on the left-hand pane and you choose Dev Spaces, and you have to enable it. It's not enabled by default, but it's very easy to turn it on. You just click right here and say yes, and after a few minutes, Dev Spaces will be enabled. Okay, for now, that's all I'm going to have to do in the Kubernetes cluster side of things. Now I'm going to move over to Visual Studio. And this is where the fun begins. I have here another one of my easy .NET Core MVC applications that I just created using a Visual Studio template. I'm not going to show you all that in this demo. All I've done is add it to source control. I haven't touched a single thing in the code here. If I run this, it'll run as they always do in IIS Express in my browser right here under localhost, and there it is. Okay, that's that. Suppose I want to run it in Kubernetes. All I need to do is go up to the debugging environment bar, and I have a choice here, Azure Dev Spaces. Now, in order to see this, I have to have the Azure workload installed in Visual Studio. This, by the way, is Visual Studio 2019. In Visual Studio 2019, you just install the Azure workload into Visual Studio, and you'll have this. If you're in 2017, there's an add-in that you have to add as a Visual Studio extension. But once I choose Azure Dev Spaces, take a look at what's going to happen over here on the left in Solution Explorer, right? Normally, when you choose one of these, nothing happens in Solution Explorer. But I'm going to choose Dev Spaces, and it's going to ask me, where is the Kubernetes cluster that you want to use? Now, it found it real quickly because I have Visual Studio already connected to my Azure subscription. Okay, if I didn't have it in my subscription, I'd have to go and set that up first, but that's already done. It went and looked through my subscription, and it found all the Kubernetes clusters that I have, namely this one. And finally, it's asking me, what space do I want to use? Okay, I can use Dev, which is a space I created. Default is there by default. If I haven't created any other spaces, then it'll use the default space. I'll leave it on Dev for now, and I'll talk more about why you would use different spaces in a moment. And then I have this checkbox here for public accessibility, whether or not I want the Kubernetes container to be publicly accessible. I'm going to check this now because it makes my demo easier. In reality, I might not. I might prefer, and particularly if I'm installing a microservice that I don't want to be publicly visible, I only want it to run within my cluster, I would not check this. But for demo purposes, I will. Okay, so I'm going to click that. And now if you look on the left, you can see that some files have just been created and added. You can tell because they're in source control and they have little plus arrows, plus signs by them. Here is a Docker file, which has the instructions for building a container in Docker. Here is a YAML file, which has instructions for deploying the containers into Kubernetes. And then there's a folder that's been added here called charts. And in there are a bunch of new files. These are Helm chart files. Chart is the cute name that Helm uses for configuration files. This will tell how to install my on-prem web app into the containers once they've been deployed into Kubernetes. Now, the neat thing is I don't have to understand any of that up front in order to now run my app in Kubernetes. All I have to do is just click the usual debug arrow. Now, as I'm doing that, I'm going to jump into the output window because there are some things going on in the output window that you wouldn't normally see. Well, it happened so fast that I didn't get a chance to show you. But if you take a look at the URL here, you can see that we are running in Azure. This is the dev space that I said we were going to run in. Here's the name of my app, and then some more stuff that means something to Azure Kubernetes to identify the location of this particular service. Okay, it's running in Kubernetes right now. Well, I'm going to skip this, I guess. And the other thing I want to show you is I can debug it easily enough. If I just put a breakpoint here in the method that is going to run the privacy view of the application, and then I click on privacy. Okay, bing, I've stopped in the debugger. I now have all my debugging tools available to me. Now, there isn't any interesting code here, but I can see variables and so on, stack trace, whatever. Okay, as soon as I say continue, then the privacy policy page comes up. Okay, so that's how little it took to get a on-premise application running in Kubernetes using Azure Dev Spaces. Now I'm gonna stop debugging and I'm gonna close this because now I'm gonna show how this would work in a more realistic setting. This is a typical kind of a DevOps process that you can enable using your source control system and a continuous integration, continuous delivery pipeline, and the Azure Dev Spaces. So let's say that we've set up an AKS cluster for developers to use, and we've created a default namespace in there, which we're calling Dev. Dev corresponds to the shared branch and source control, where, you know, when developers work on individual microservices or individual features of an application, they'll create their own personal branch in the source control system. Check that out. Start editing code and testing the code they write in that branch. Well, when they want to deploy it into the Azure Dev Space environment, they will publish it or deploy it into a personal space that they've created for themselves, separate from the dev space, so that no one except them can, you know, see or be affected by the code that they're working on. But that personal space will be tied back to the dev namespace so that any parts of the solution, anything that's running in the cluster that they're not working on, will be available through the shared dev namespace, and they can incorporate that automatically into their personal space. Okay, once they're done, let's say Lisa there finishes her work on her particular microservice, and she checks it in and pushes it and merges it into the master branch in source control. That will trigger a build in the continuous delivery pipeline. That at the end will invoke Helm to install the new code into the shared dev namespace. Now, I'm not going to demonstrate the continuous delivery part of this today because it doesn't really affect Azure Dev Spaces, but that shows you how a complete cycle can work so that developers, again, don't have to set up the Kubernetes environment on their local machine. They can all operate in a shared environment, and that means since you're not running on your local machine, you don't have to incorporate all the other parts of the cluster that other people work on into an environment that you're running yourself. So let's take a look now at how this works. I'm going to go into two different solutions now. Actually, let me close this so you can see things better. Okay, so I've divided up. I've now got two Visual Studio projects. I'm running these as two separate visual solutions in two different instances of Visual Studio. This is a recommended practice already for microservice development. You put each microservice into a separate solution and run it in a separate Visual Studio instance. There's one specific reason for that, which I've discovered in using Dev Spaces, which is if you want to debug more than one application in Dev Spaces at the same time, you can't set up multiple projects to debug simultaneously in your solution settings. If you want to debug two at the same time, it's better to have them each running in a separate solution in a separate instance of Visual Studio, and then they can both debug simultaneously. But that being said, the way this works is this is the front end, and I'm going to consider the front end to be another microservice. It's an ASP.NET Core MVC application. It's actually the same as the one I just showed you a minute ago. The only difference is that in the privacy method here in Home Controller, instead of just spitting out text of its own, it's making a web API call with a standard HTTP client to another microservice, which is this one, policy service, running in the same Kubernetes cluster. So here's the policy service, which I want to show you. Let's close this, and here we go. So I have a policy controller running in this project. This is a .NET Core Web API project, and it's got a controller called policy, and it will return the company's privacy policy, which isn't really very far along yet. Okay. This is already set to run in the dev namespace. So if I just hit Control F5 here to run it, it'll fire up for a moment, and then I should quickly see this. Oh, by the way, let me, this may take a little bit longer. I'm going to show you the output. So here I can see the actual steps in my output window that Visual Studio is doing in preparation of getting the thing launched and running in the dev space cluster. So here it is. That's great. And now the front end application, I'm going to launch that. And again, it's going through the setup stages that I can watch here in the output window. And hopefully this will not take too long. Okay, while I'm waiting, I'm going to go back and show you the code a little more closely. If you look at this, this is the URL that the front end app, here we go. This is the URL that the front end app is calling in order to get the policy from the privacy policy from the policy service. This is not a public URL, okay? It says policy service API, API controller, but this is not an address that you can find if you just type it into your browser. This is meant to be an address within the Kubernetes cluster. And there's a little bit of magic going on here to allow the Kubernetes cluster to find where the service is. I'm taking a special header that's being added by the Azure Kubernetes runtime. It's called AZDS, Azure Dev Spaces, route Azure something. And it's just passing that header along to the policy service. And that's enabling the Kubernetes cluster to locate where the policy service is, so that when I now click on the privacy tab here, there's the there's the message that's being returned back from the policy service. Okay, well, that's just the warm-up for what we're going to do now. Let's say that I've been assigned to go in and fix this policy, so we don't really want to have a placeholder here anymore. We want to start putting in the actual Azure policy. So I'll just go ahead and change this to a new beginnings of a new privacy policy. All right. Now that obviously needs a little more work, but this is iterative development, so we'll start with that. But the thing is, as I'm working on this, I don't want anybody other developers to see or be exposed to the work I'm doing here with this policy service. So what I'm going to do is go to the properties of the policy service and specifically go into the debug setting, which you've all seen before. And you'll notice that when this is part of what the tool did up here when I chose Azure Dev Spaces for this project. It put the information that I entered previously in here and says, okay, we're going to run this in the GAB 2020 AKS cluster, and we're going to put it in the dev space. Well, I'm going to change that, and I'm going to create a new space just for me. So I go down here at the bottom where it says create a new space, and oh, what the heck, let's go ahead and call it Richard T. Broida. The key is, though, I have a choice of either having no parent space, or I can use one of my existing spaces as a parent space. And when I do that, all of the containers that are already installed in the parent space are going to be available in this Richard T. Broida space that I'm now creating, unless I override them. So I'm going to say OK, and click that. And after it thinks for a minute, it says OK. I'll save that. All right. And now I'm going to run it again. Just hit Control F5 here. Okay, takes a minute. Not a minute, takes a little less than a minute. Can get confused here when you're in the output window, because if you're in the build, tab, it won't show you much about Kubernetes. But if I switch to Azure Dev Spaces, it will. Okay. And because this is already installed, all it's really doing is updating the application code. All right, when we get to waiting for container, that just says I'm waiting for the container to activate, and we should be going in a moment. So here we are. Now look at the URL. Before, this just said dev policy service, blah, blah, blah. Now it says our Broida, which is the Richard T. Broida, and then a dot, and then the letter S. I think the letter S stands for slash. I'm not totally sure. But anyway, if I took that out, we would get the old version of our privacy policy, because that's what's still running in the dev space. But here in the Richard T. Broida space, it's now got my change that I just published. Okay, if we go back to the web front end, which is running still in the dev space, and I refresh this, I'm still seeing the old privacy policy, but I can paste that prefix in here, and now I'm actually I'm not running in the dev space anymore. I'm running in the Richard T. Broida space, but the Richard T. Broida space knows that it can find the front end web app in the dev space, so it just pulled it in. And then this little magic code I was telling you about here in this web API call is automatically routing that request to the instance of the or to the space, the Richard T. Broida space, where this version of the policy service is running. Okay, so that gives you a quick view of how different people can be using different versions of application code in a single shared cluster.